Hello, so here we are. We've got our scene, we've got our overlay, and this is going to be super quick. I just want to apply an effect to add some warping to this blue overlay here, so it sort of looks like a little bit like a curved screen. So just for fun, let's jump in and have a go at this. So what I'm going to do to start with is I'm just quickly going to do a little bit of a trick here. Of course, I'm going to go over into the screen shader. Here we are. Okay. And I'm just going to take this calculation. Remember from previous video, this calculation will take this texture coordinate from the space -1, 1 and map it into the space 0, 1. So I'm going to make a texture coordinate, which I'll call pos. So what I'm doing is, instead of sending through a texture coordinate in the range 0 to 1, I'm actually sending it through in its raw form between -1 to 1 in the X and Y. And then I'm fetching that down here. I'm going to apply any sort of warping that I want to that texture coordinate, and then finally going to map it back over. So a thing to remember, let's go ahead and run this just to verify that it is working, because right now I should just be taking that info and not doing any transformation at all. Should be the this is live coding, by the way. Oh, of course, because I'm taking that texture coordinate instead of the pos. Okay, great. Just the regular overlay. Okay, cool. So I'm going to play around with this a little bit. So if I look on the screen, sort of on the right, I'm at 1. At the left, I'm at -1. If I were to sort of double the texture coordinate, then we'd be cramming more texture into the space. So if our X coordinate gets doubled, it goes over to 2, it will be wrapping around and grabbing a repeat of the texture. To the right, the left, we can do the same in the Y. So this is just a really confusing way of me saying, let's see what happens if we double the texture coordinate. So we'll say pos equals 2.0 times pos. Give that a go. Okay, so as you can see, the X and Y are being doubled. This is wrapping around. We're making repeats of the texture. Okay, so the same thing would happen if I started to multiply by a smaller number. We'd be stretching in, we'd be zooming in on the texture. A very interesting effect is if we apply what I would call like conservative maps. So if we go Desmos and we look at a conservative map, what I mean here is a function such that on the range 0 to 1, we're injective. Oh, we don't need to be injective, do we? We just need to cover the full range from 0 to 1, but in an interesting way. So if we just go y equals x, that's nothing interesting at all happening. If we go y equals x squared, let's see what happens there. So let's go square the position, see what happens. Not that exciting, actually. It's sort of applied a bit of a stretching at the boundaries. And what's happening there is, if we look at this graph, we can see that as we get close to 1, the texture coordinate would be changing very quickly, which would sort of around 0, it's changing very slowly. So it's stretching out the texture, and around 1, it's compressing. So that's why we're sort of compressing at the boundaries. We could go over and say, well, there's another sort of conservative map, which is square root x, right? So if we see here, this looks like the texture coordinate would be changing very quickly around the center, and then very slowly around the boundaries. So the center would sort of be pinched together, pinching that fabric around the center, and then we'd be stretching out the boundaries. Let's have a look at that. So I'll say, let's go square root. And this is really messing up in the negative ranges for the reason that negative of square numbers is not defined. So what we could do is we could take the sine of our position and then multiply it by the positive version, right? So positive square root is totally defined, but then we need to conserve the positive and negative, and that's what the sine operation is doing. So that will sort of put that sine back into the numbers. Here we go. Okay, yeah. So again, around the boundaries, this is really stretching, which is why I really zoomed in. And if we had a full texture, you'd probably see a lot of compression around the center, but we're not really seeing that. That's fine. Cool. So on to the stuff that I actually wanted to do today, which is applying a warping effect. So what I want is I want to sort of, like, what do we have? Yeah, so if I look at a heads-up display from like Halo, for instance, there's this sort of curving effect. So if I look at this, I'm thinking, okay, as I go left to right, the texture coordinate isn't changing much, but then as I go left to right, horizontally, it's changing. So what I'm going to do, so at the moment here, what I'm doing is I'm taking in the texture coordinate and applying no operation. If we look at this, we should pretty much get the straight overlay, just rectangular. Okay, so what I want to do is when I'm at the center of the screen, I want to pull this overlay towards the center on the top, and I want to pull it up towards the center at the bottom. So I need some sort of pulling function which is maximized when x equals 0, and then it tapers off as x goes away from 0. And it turns out that is cosine, right? So if I look at cosine x, we've got the maximum amount of pull when x equals 0, and then as we go off to the right or left, that pull decreases. So think of this as how far the screen is being pulled up or down. Okay, so what I'll do is I'll add cosine of the x texture coordinate, and I'll give that a go. There, we've got it. Okay, so see how the top is being pulled down, but then pushed down, I guess, but then the bottom's also being pushed down. So there are a number of ways I can approach this. The simplest way is to multiply this by the sine, SIGN, of the y coordinate. Because if we are on the positive side, positive end of the screen, we want to be pulling down. If we're at the bottom of the screen, we want to be pushing up. So I guess, is that negative? We'll do this and see what happens. Maybe we get it right, maybe we get it wrong. We can always adjust. Okay, that's looking a little funky to me, so let's try the other way around and see what that looks like. I changed my mind, that sort of looks worse. Okay, we'll go with the original. And I'm also going to try changing this to SIN, just for the speculative reason that sine is a curved function, so it'll be a little easier on the eyes, a little more continuous. That's looking pretty good, actually. So what I'm then going to do is I'm going to decrease that amount of the magnitude of that push. So I'll introduce a coefficient, something like 0.25, I guess. It's not an exact science, none of this is. There we go, that's looking pretty good. And then I want to handle cases where I'm going outside the bounds. what I could do is I could jump into the material class and give it a behavior like clamp to edge or something, but that would involve editing the material class, and I don't feel like doing that. Plus it wouldn't even work that well. So there's an option that we have in WGSL, and that is to discard fragments. So these cases, if we were to look at the texture coordinates, they would have a Y coordinate, which is either negative or bigger than, I guess, yeah, they'd be out of bounds. So either bigger than +1, less than -1, or if we look at the recentered version, out of the range of 0 to 1. So what I'll do is I'll go here and I'll say, I'll look at the Y coordinate and I'll say if that's less than -1 or greater than -1, then we're out of bounds, and we'll simply discard that fragment, so we won't draw that fragment. And this will have the effect of clipping the amount of texture which gets drawn. Cool. So there are still modifications that we can make to sort of stretch this so that it's not just hanging around like this, but I'm going to keep this here for now because it sort of shows the effect. Let's just try this anyway. Okay, so that's a little off. As a matter of fact, that's a lot off, so I'll just leave it as it was. It's very easy to get into refinement culture here, but counterpoint, getting the thing looking correct probably doesn't classify as refinement culture. But yeah, and that looks really bad. I don't know. That's a little better, I guess. Point is, we've still got that warping effect. So yeah, there we have it. This is pretty fun up here. Ready. So there we have it. You getting dizzy? Sorry. Cool. So in this video, we've pretty much taken that texture, that overlay, and we've applied a bit of a screen warp effect to it. Later on, if we have a fuller heads-up display, all we need to do is render to that texture, and then when we composite that together, that will automatically get that warping effect on it, which I think is pretty cool. But that will be it for today. So I hope you had fun, and I will see you again soon. Bye. Hi, so I just wanted to take a second to say thank you to all of my channel supporters. If you would like to support the channel, it's $2.50 a month. That's all I ask, but it's not expected. If you are not able or willing to support the channel financially, the best thing you can do is the usual: like, comment, subscribe. Let me know what you'd like to see. Let me know what you're enjoying, because I am trying to make the best educational content that I can under the constraints. So with that out of the way, really big thank you to Antonin Karet, Dankiel Foles, Declan, Endelon Studios, Isaiah Meyer, Mathieu Derick, Moim, and Shreya. Thank you so much, my dudes. I really do appreciate it. It's fuel for the fire. Keep me going, keep me motivated. But yeah, have a great one, and I'll see you again soon. Bye.